You come up with an idea, you want to measure something that's going to advance the science, and so you go out and you build it and you do it. And by doing that, you put better quality data into the scientific community, which pushes the science forward, which then means you need to make new observables. We never close a question, we usually just find out that it's more complicated than we originally thought.
Welcome to the PAM Talks. Each episode, we interview a new physics and astronomy mentor, exploring the universe through the lens of diversity. My name is Garrison, and I am a master's student in physics here at the University of Calgary. I study complexity science, specifically as it applies to neuroscience. I'm going to be the host of our PAM Talks today. I get the privilege of interviewing someone who works in a completely different area of physics than me. Hopefully, we'll all learn a lot. I'll be interviewing Dr. Anja Spanswick. Dr. Spanswick is a recently tenured assistant professor at the University of Calgary. Her research focuses on space physics and instrumentation. She holds the position of Canadian Research Chair in Geospace Dynamics and Space Plasma Physics. Dr. Spanswick has made it her mission to assemble a multidisciplinary team to advance space physics through research and development of new technologies. Today, she is going to share with us her journey and help us explore this young, exciting field. Coming up next, my interview with Dr. Anja Spanswick.
My name is Anja Spanswick. I'm an associate professor now here at the University of Calgary in the Department of Physics, and I'm also a Canada Research Chair in Geospace Dynamics and Space Plasma Physics. A very long title.
That is a big, long title. Congratulations on getting tenure. That's very exciting.
Thank you very much. Long journey.
So that long title, can you tell me what space physics is?
Sure. So space physics, at least in Canada, it's not a very common field that you find at many universities here. I think it's sort of University of Calgary, University of Alberta, University of New Brunswick, Saskatchewan, but so U of T and UBC, they don't have space physics programs. So it's a relatively small community. And what it is it's a branch of physics where we're studying basically space plasmas. And that can include, the Earth's upper atmosphere, all the way out to this, what we call near Earth space environment, where most of our satellites live, all the way out to the sun, which of course is spewing plasma regularly. And so the field that I'm in really is, I would call it geospace. That's why there's geospace in my CRC title there. But geospace plasma physics, so I'm studying the plasma around the Earth, connected to the Earth's upper atmosphere, which of course is highly dynamic and where all the action is.
Just for our listeners who may not be familiar, it sounds really similar to astrophysics. Can you describe a little bit of the distinction?
Everybody calls me astrophysics. Let me just think of the best way to put this. Like, how do I explain it to my dad, right? Because what I normally say is, so I view the difference between astrophysics and space physics really as the ability to get to that plasma. And so in space physics, we're usually dealing with direct measurements of the plasma environment through satellite measurements or rocket measurements of the upper atmosphere. Or we are remote sensing, which is a lot of what I do from the ground, which is very similar to astrophysics. But we're really about the local plasma environment and studying the plasma physics for regions that we can access. My research group, what we do is we're designing and building instruments to remote sense the space environment, right? And what we're doing is we're doing that from the ground. So we're looking at impacts of the space environment on the Earth's upper atmosphere, and we're relating those impacts to plasma physics or plasma processes that are occurring in the larger Earth's magnetic field environment or the magnetosphere. And so we're studying kind of the coupling between the space environment and our upper atmosphere to get at the plasma physics of the space environment. By doing that, we're also looking at the impacts of that space environment on technologies, such as HF radio communications or satellite spacecraft charging and things like that. I'd say there's 2 arms to my program, or even 3 arms to my program. There's the instrumentation development program. There's the core science of the space environment. And then there's the applications-based space weather research and its impacts on technology.
Okay, so I wonder, how did you get to space physics? Because again, it's not a very common field. How'd you get there?
Well, so I was one of the very lucky people, I think, like most people in physics, that I had a very good and very inspiring, I would say, high school physics teacher. Philip Heidebrecht, if he's still out there, a shout out to him, because he created such a wonderful environment in our physics class that I fell in love with physics. So yeah, I knew in high school that I wanted to go into physics. despite being from a medical family, I would say. And there's a funny story there, because I do come from a primarily medical family. My mother was a doctor, my father was a doctor, my stepmother was a nurse, my stepfather's a doctor. So we are medical through and through. And I think the expectation was always that I would be a medical doctor. This was just the standard in our family. And I can still remember the day telling my mom, she was standing in the kitchen, and I remember coming home from high school and being excited that I had decided, I was going to go into physics. And I remember telling her, Mom, I think I'm going to go into physics, right? And she gave me that very characteristic mother, nonverbal kind of response. And then nothing. I didn't hear anything. And then the next day I come home again from school and I find this wonderful book sitting on my place at the dining table, big, thick book entitled How to Get into Medical School. And then from that moment, I don't know. I mean, it was clear, but she had also said, you can do physics as a first degree. And so I don't know.
I mean, you still became a doctor, just a different kind.
I did. We joke that I'm not the useful type of doctor, though, in my family.
I don't know. I feel like there's some usefulness to physics.
Yes, it just depends on the types of problems you're going to solve. But
So I think my question was, what was your experience like at university?
I would say, so I wasn't. I wasn't really one of the students who was probably ready to go to university at the start. I would say I spent my first 2 years not attending class. So I was in astrophysics to start, kind of trying to find my way. Astrophysics didn't work out, clearly. Grades weren't that great, wasn't really engaged. And then finally, in my third year, I sort of had one of those reflective moments that we all have where we look back and go, this isn't going to end well. And so that was when I started to go to class and things really turned around. I found the joy that I had had in high school with physics. I finally found it in third year, I think. And that's when the grades started coming, and that's where I started to get really engaged, I think, in physics.
I think that's a really inspiring story to hear. It's not too late. You can have the stumbles and you can grow and change and find that love again.
Yeah.
So, what was your first experience with research?
Okay. So, I was in third year, and I think a lot of students, there's a lot of, summer research opportunities that pop up in physics, particularly around here. There's lots of research jobs. You can go and usually find a summer job working for a prof on a research project. And that was the summer after my third year. So my grades had started to improve, but I still had this kind of wreckage, I would say, behind me. And I had looked around and I was like, you know what, I'm going to apply for some of these summer jobs. And I had seen a job that I was super excited about rockets, like rocket science. It was in space physics. And I had intended to apply for that job. So I went and I talked to the prof. And as I said, there was some wreckage behind me in my grades. And it turned out that because of that wreckage, I was not a candidate for that particular job. But it did put me in a location walking up here on the 6th floor of Science B, where I was walking back kind of rejected from that discussion. And I ran into another prof who happened to be teaching me thermodynamics at the time. And he saw me and he said, Emma, what are you doing up here? Right. And I was like, oh, I was applying for a job and, it's not, that's not going to work out. He just looked at me and he said, you're looking for a job? I went, yeah. And he's like, come here. And he dragged me into one of the labs up here, sat me down, and he just started showing me data from auroral cameras that were looking at the dynamics. And you see the aurora just kind of going nuts and lots of different features in the aurora. And he just looked at me and he's like, what do you think? And I just said, it's cool. And he went, all right. And that was that. All of a sudden I had a summer job.
Your qualification is, I think that's cool.
Pretty much. That was my only reaction.
Awesome.
This is cool. And then all of a sudden you're hired. I'm like, okay. And so that's how I ended up in kind of remote sensing here. I stuck around in that lab. I did my MSc in that lab and then my PhD, and I learned all about the instruments. I started designing instruments myself. And then here I am today, all from one summer job.
It's amazing when people can see your potential because you obviously had it. Did you go directly from PhD, postdoc, professorship, or did you go a different direction?
Oh boy, I was convinced. I was convinced I did not want to be a faculty member. I mean, I found research fascinating, but at the same time, I loved, and I still love, the hardware aspect of it, the aspect that couples to engineering. And a lot of people would say, if you look at my group from the outside, we straddle that physics engineering boundary. And indeed, my team has tons of engineers, computer scientists. And so I had found that I really enjoyed that hardware side of it, the application side of it. And so I was convinced I was not going to be a faculty member. I went from my PhD, I stayed on here at the U of C for a few months, and then I went and was a visiting scientist down at Los Alamos National Laboratory in the US for their intelligence and space research group. Did 6 months down there, and then came back to Calgary for an opportunity to work on a spaceflight instrumentation project. So designing an auroral imager to fly in space. So I came back here, I was managing the group. So you're managing a group that can go from sort of 10 people up to, I think we were about 26 people at one point, staff with, probably anywhere from about 10 to 30 active grants at any given time. I think our payroll hit 2.6 million one year. So I was managing large research projects, lots of research projects in this kind of web of activity that went all the way from designing instrumentation, writing proposals, contract reporting, data product design, everything through to supporting the science. And so my role was not a traditional, postdoc role. And I spent, I think, 10 years in that kind of managerial, technical / science role before a faculty position became available. And I was like, okay, I think I'll go for it. And then I wound up here.
I think that is partly unique to the field that you're in, with this opportunity to do a more the more engineering side.
What do I call it? I call it a scientific technical blended kind of role, because it was kind of scientific, technical, and managerial role. Like I know more about spreadsheets than I would ever care to admit, and tracking large budgets and how to budget for very long-term missions and things like this. Yeah, it's one of those skills that you don't really want to develop, but you do out of necessity.
I I think it's interesting to hear that not many professors have this sort of experience outside of an academic space. And I wonder how your management experience affects how you build a team here.
So that's a great question. I often kind of compare our culture and our team to something that's more akin to a startup company than it really is to an academic environment, because we've built a real transdisciplinary team here. We have to cover off various skill sets. We need to do the detailed science, and we need to understand the science and understand the instrumentation to be able to design or ask the questions about what are the next observable that we need to be able to push forward, right? What's the next piece of information we need? And then we take that into the engineering realm, kind of blended with science, and we figure out, okay, how would you possibly do that? How can you get more information for this system? And we play that game with a lot of concept studies and things like that. And so we kick that idea around for a while. We want more information. We want to optimize the instrumentation. And then we throw that over to the solid engineering side, where it's like, okay, now I know I need to measure this. How am I possibly going to do it? And then that goes through the engineering cycle, that goes through the robustness, the optics cycle. We go all the way through, right, to the idea that I'm going to throw an instrument in the middle of the Arctic and I need it to run 24/7, not complain, right, with 99.999% uptime. So we go all the way from, I have an idea that I need to be able to measure something, through to I need to put an instrument in the middle of nowhere and have it run for 20 years without having to touch it. The breadth of activity that has to go on to be able to span that breadth of activity is huge, which means we have a team here that we go from, engineering students who are in electrical engineering, mechanical engineering, software engineering. We've got geomatics engineering now involved, through to physics degrees. We've got engineering physics in here. We've got computer science. At one point, I hired a history major because he was great at making videos, promotional videos. So we bring anyone and everyone who has a skill set and an appetite to contribute to this kind of dynamic environment.
That's really cool. I wonder, with such like a large and diverse team, with everyone having different backgrounds, how do you keep a positive team culture?
That is the manager's problem. I think with any of these kind of teams, right? You hit it right on the head there. So what we've got in this team here, or in my team here, we've got a group of senior staff. Those are the people that I rely on the most. I've got a senior engineer, senior computer scientist, a project manager. And so I have a core team who I can rely on very closely and very heavily. And then we augment, of course, with students, right? And you need those students no matter what they're working on. Like they might be working on the real-time protocols that will bring back data from the field, right? And that person's sitting next to someone who's a physics person who's looking at the statistics of some behavior of some plasma process, right? So, and you've got them sitting next to each other. And so making those students feel connected is right at the top of our list here and making everybody feel welcome and that they're contributing to the overall goal that we have. So all students in our group will be paired with a senior staff member because the team's large enough that I can't interact with everybody on every single day. But all of our students have not only the cohort of students that they're in, but they have access to the senior staff. And the senior staff and I meet a lot. And one of the things that we are very clear on in that group is the idea of outcome. And by outcome, I mean there's you can think of that in multiple ways. So there's the technical outcome, right? We need to get things done. But there's the other outcome of, how the student or how people who work in our group feel about their experience and what skill sets they gain. So there's those kind of three axes, right? We need people to develop the skills. We need people to feel like they are engaged, feel like they're contributing. And we also need to just get stuff done because we have a lot of stuff to get done. And so the senior staff and I, this is an ongoing conversation, and we are always, always talking about this in our senior staff meetings. We're identifying, what students need perhaps a bit more support. Can we pair students together to try and create more support? Can we create those networks within the group? And also providing, what students are ready for more, because that's one of the things you get students that need more support, but you also get students that are just like they're hitting it out of the park. And it's like, okay, what can we do for this student to make sure that their experience goes to the next level? So I would say when we're creating that culture, there's a couple things we're very aware of it. We try to individualize it to each person who's in our group to try to maximize what they're getting out of the group and what we're getting out of them, because those two go hand in hand. And yeah, so some students, when they come through, they get some tremendous experiences if they engage and they do well. We got one student here who's doing his internship. He's a physics student doing an internship with us for 16 months. We just got back from Colorado, took him to an international meeting for space science. He's an undergraduate and he was helping lead a session at a workshop. And so he's coming away with like a fantastic experience. He's already got offers like that when he's done, he can go and work at NASA. And I keep telling him he should stay for a master's. Yeah, it's about that individualized approach and making sure that you understand enough about the members of the group that you can meet their needs so that we can kind of move together.
So I've heard two sort of things that I want to ask you about to focus our conversation about the future work in this area of space physics. One that I found really interesting was this concept of observables unique to space physics. And then the second is this truly transdisciplinary nature of the work. Do you have any examples of things that you're working on that maybe are interesting in those spaces?
Oh boy. Yeah. I mean, I kind of described it, right? The idea of cradle to cradle operations, right? You come up with an idea, you want to measure something that's going to advance the science. And so you go out and you build it and you do it. And by doing that, you put better quality data into the scientific community, which pushes the science forward, which then means you need to make new observables. We never close a question. We usually just find out that it's more complicated than we originally thought, right?
That's so physics.
Yeah. And so what we do is you'll find that there's an evolution of the instrumentation that we operate here at the university. And we are on the verge of the next big revamp in that instrumentation. So it was announced, I think last year. We're very close to finalizing the grant, but it's a new instrumentation project, just over $15 million Canadian, to design, build, and deploy the next generation of space remote sensing infrastructure across Canada. So this one's being done in partnership with NASA, funded by the Canada Foundation for Innovation. And we have to, in the next 5 years, we have to put out 137 instruments across 22 remote sites across northern Canada and into Alaska. So we got a lot of work ahead of us to get that next generation observable, but it's the next big thing. And it will require a big, as you said, transdisciplinary team.
Okay. So I remember from your story about, stumbling into space physics, you saying that you thought it was really cool and you talked about the aurora.
Yep.
I hope for our listeners, can you describe some of the things that you think are cool about maybe the aurora or space physics in general?
Sure. Yeah. So I'm always blown away when I start thinking about, the system that we study in magnetospheric physics. So the kind of the smaller branch of space physics that I work in is this kind of geospace area, where what we're doing really is we're using the ionosphere or the Earth's upper atmosphere. We used to call it the TV screen of the magnetosphere. When you think you're seeing something dynamic in the aurora, you're seeing some, either patches that are turning on or off, or a very dynamic display that's just exploded over your head. When you're seeing that, what you're actually seeing is plasma processes that are occurring much, much further away. And those plasma processes have huge scales associated with them sometimes. And so you're looking at things that, when we talk about distances, we start measuring in Earth radii at that point. We're not into the astrophysics realm, right, where we're talking about light years, but we're talking about Earth radii. And so you're talking about things that are 10, 20 Earth radii away from the Earth. And those are what creating these kind of dancing lights that you're looking at. And nothing is more exciting than trying to piece that together from the ground with different auroral images, and you're trying to stitch all this information together, and you've got different information coming from different instrumentation, like different auroral wavelengths, or we're looking in the HF radio bands, or we're looking at magnetic field measurements, and trying to piece that puzzle together of the entire space environment, to me, it's incredibly exciting.
I think that's incredibly neat, especially recently there's been a lot of auroral activity. A lot of people got to see it. So I think it'll be interesting for our listeners to hear kind of about the research that's being done in that area. One of the things that I was wondering about in your background is you are from here. You went to school here and you now work.
Yes.
What is it like to have that localized journey, or to have people who maybe were teaching you that are now your colleagues? What is that journey like for you?
So there's two parts to that question, or at least I'd like to split it into two parts. Because the first part about, having the journey and going through, because I did do my undergraduate, master's and PhD at U of C, but at no point during that kind of research journey did I ever feel isolated, because the space physics community, we're a very collaborative community. So even though I'm here, I'm sitting at U of C and I'm working on some things. When I was in my master's, I was able to go down and visit Los Alamos National Laboratory for 3 weeks. You're working with scientists at NASA, you're working with scientists at UCLA, right? And you're having these ongoing conversations. And at no point did it matter that I was sitting at U of C. It didn't impede in any way my research. If anything, I was advantaged because I was here, because this was the place that was producing all the data. And so I got kind of the front row seat, right? So if anything, people were just kind of coming to me for like, hey, I want to work on this event, or we noticed something cool over here. Can you check the ground data for us? So I never felt like being at U of C for those 3 degrees had any impact on my career whatsoever. And if anything, it just it magnified it because of the role that University of Calgary plays in the data landscape for space physics. And so that was great. On the faculty front, like now that I'm a faculty member and I'm now a colleague of the people who were teaching me, that's interesting. That's the totally different, because it's a different social dynamic. And again, what I found here, I have found nothing but support. And even those moments, we all go through our imposter syndrome, and I will still never forget the first time I was teaching Physics 259. Oh my God, I was so scared. I was like, I know this is first year. I'm like, but there's going to be something. There's going to be something. This is not going to go well. But all I felt from it was team taught course. Everybody, including people who had taught me in undergraduate, right? I'm teaching with them now. Nothing but support. I feel like this is a great place to be.
I hear something interesting in what you're saying that kind of relates back to your creation of this team, this collaborative team, and seeing people's potential. I think that evens out the dynamic of like, I'm the professor and you're the student, And instead, it's about seeing each other's potential and fostering a journey where you can be colleagues at the end of it and feel that support that you just described.
100%.
What were some of the experiences that made you feel really connected with the space physics community?
Great question. So the space physics community, it's one of these things I don't quite know how to describe, because there's this community atmosphere within space physics that I believe it comes from the fact that the space physics community is a relatively young community in comparison to other physics disciplines, right? You can trace quantum mechanics back, but you look at space physics and it owes its origins to, early ionospheric measurements. And to be honest, it's the space race of the late 50s and early 60s. And so you find that community, if you look into that community and some of the founders of that community, you find, first of all, you find a little bit of diversity that you wouldn't, I think, find, or at least publicly, early in the start of some of the older disciplines. And you go into that community and you've got very strong role models who are very also aware of the culture that they're trying to create. And so I can remember back to some of the early meetings that I went to and learning about, people like Margaret Kivelson and Michelle Thompson. So you've got these women who were basically some of the founders of the field, and they're totally accessible, like totally. And they're having conversations with you, and they're on teams, with other men who have the same thoughts about diversity as them. And so I will never forget getting pep talks from some of the senior members of our field who you'd think you would never have access to as a master student. But you're sitting there next to your poster and you're kind of feeling, like, oh, this isn't that great. And you get senior members of the field who are coming up and talking to you about how great this is and how this fits in with things. And so that kind of community atmosphere, and I'm not old enough to comment on how it started, but I have to believe it came from that diverse team that was at the core of space physics very early on, and the tone that they set for the field.
I think it's amazing that you got to work with them directly. Not everybody can say that.
Yeah. And every field has these people, right? We use the term bigwigs, right? Like, who are the bigwigs in the field, right? And they were always so accessible, the bigwigs in space physics, and they knew your name. That was the best part about it, right? Because it's a small community, they knew your name. And still to this day, I go to meetings now, I get invited to sit on panels, and I'm sitting with some of these bigwigs, and they see me and they're like, "Hey, Emma, how's it going?" I'm like, "This is great." So it's a supportive, small community.
I see the through line also from these kind of formative experiences in the field to the kind of work culture you're trying to create on your team. I really admire the way that you're trying to continue to foster this sense of community within the field.
It's an avenue that I think a lot of our field, I mean, we're not without problems in our field. Obviously, I mean, all fields have issues, but I feel like the space physics community has done a lot to try and bring those issues to the forefront. And you'll find things now, like you go to the US National Meeting and they're having open discussions and sessions on EDI, right? Like, there's actually a session at a major scientific conference on EDI, and they've integrated it into their culture. And so I think it's fantastic. Everything's about just, let's have the conversation.
Well, Dr. Spanswick, thank you so much for coming and doing one of these PAM talks. It was a fascinating conversation all about community, diversity, transdisciplinary work. I thoroughly enjoyed myself, and I'm sure our listeners will too.
Thank you for having me.
The PAM Talks gratefully acknowledges the support of the University of Calgary Graduate Students Association Quality Money Grant Program.